And
Yeah, that-
Velva, oh yeah, it's all very well.
One
Filter.
Yeah.
There you go, canister.
Where's the obstruction?
Fuel tank pressure sensor sometimes. Turn back the mushroom.
So the overall, it looks like that. So for the vent valve, on some cars you have the actual vent valve. On some cars you have the leak detection pump that usually combine the function of the vent valve. Vent valve you usually have on the cars that have the MV EL system. So, or so how the system works? Who knows? What is the two main operation status of the system?
It pressurizes the tank when you shut the car off, right?
I think it's so that when you're running it, it doesn't have too much pressure in the fuel tank itself.
No, it's
So we're talking about the evap system?
Yeah.
yeah. So the overall,
It's-
it's two main operations.
Oh,
First one, it's accumulation.
it needed to keep hydrocarbons to
Yeah,
reduce
so-
hydrocarbons.
So when you turn off the car and go home, the vent valves go to open. So the vapors from the fuel tank, the purge valve is closed in this condition. So your vapors have only one way, from the fuel tank through the canister and go out from the vent valve. But the charcoal canister have the activated charcoal inside, so it's accumulate more carbons from the fuel. But it cannot accumulate in infinity, so it have some volume. So when you came back, start the car, you have the other state. It's called purge. In this case, that valve still open, but it also open the purge valve. So now the fuel tank is closed if you close the fuel cap. So the air comes through vent valve, go through charcoal canister, take back the oil carbonates that was previously accumulated, and purge them to the engine and burn with the other fuel. So this is the two main features. So how to diagnose the car? So how to check the purge valve?
I usually just like blow on it and it's normally closed, right?
Yes.
So if you blow on it and air goes through, then it's stuck open.
Yeah.
So that's one way of saying.
Yes.
12.
It's but it works only if it's stuck open. But if it's stuck closed, yeah, you need to run the car, wait like around a minute, then it's start purging, and just check that you have feel the vibration on it.
I do that. I'm sorry. I think
Yeah.
It's when I blow through it with no power,
Mhm.
it's supposed to
Yeah,
have no flow.
yeah.
And then you add it with you add power to it with the power probe. And
Yes.
you blow through it. It should
Perfect. That's absolutely perfect. Yes, that's right. If you check the purge valve and everything is fine, I was going to sit. How to check other system?
smoke.
Yes. But you first need to close the vent valve because it would be open. So in some cars you can run the special diagnostic test that close it manually, or you need to, on some cars you need to physically take out the filter and just plug it with something to create the pressure. So how the systems work. There is two systems. If you have the vent valve without the leak detection pump, the system, when you stop the car, it remains some vacuum inside the fuel tank. So you have the pressure sensor, just say there, for example, and the NVDL, that means the natural vacuum detection, leak detection. So the system see how fast the vacuum drops, and based on that, it check how big leak do you have. On the system that have the leak detection pump instead the vent valve, the system can test it by herself. They create the vacuum in any moment and just check how fast it will drop. On some American cars, they have, like, I know that some Chryslers, for example, they have the pump that created the pressure and check to do this check. But on 99% of cars, you have one of these two. So if you have the most popular P456 for very small evap leak, usually you check the purge valve, check everything else. If you found no leak, what it usually means?
Leak detection pump.
Yeah, leak detection pump. That's right.
So the leak detection pump, it creates vacuum,
Yes.
not positive pressure?
No, it's create the vacuum. So what is the main difference between secondary air intake and EGR overall?
You do what?
The exhaust. It's to burn the unburned. Like it's recycling the exhaust back into the lower temperatures and to reduce
NOx levels.
non-burnt hydrocarbons.
No, I'm not saying about what it do.
Oh, sorry.
I'm talking about what the physical difference on the car, what the system
Oh.
done.
The EGR is gonna have an EGR valve to let the gases, the inert gases, back into the engine, and then the secondary injection pump is gonna pump air into the exhaust to.
Yeah,
get
they
the
have
fuel in.
opposite function. One give exhaust to intake, the other one give the oxygen from intake to exhaust. So they technically on many cars they look the same. You have the tube connected to exhaust manifolds, the valve, and side have additional so the EGR usually have like to draw it. Exhaust manifold. You have the cooler. You have valve. And you have. So in EGR, it sends the exhaust valves to intake to help with emissions, reduce the temperature inside the engine. The secondary air intake, what it does, who knows?
Just to heat up the catalytic converter faster.
Exactly, yeah. The thing is the same. You have valve here, but it's usually not connected to intake, it's connected to the pump. Yeah. So the very common on the secondary air injection, what usually broke on these systems?
The pump itself.
Pump itself.
The essential.
the valve, yeah. On an EGR, say you can have the coolant leak inside the cooler, for example, stuck EGR valve, or sometimes I see on some cars that the hose coming from the exhaust clogged with soil. Yeah, so okay, everybody knows that. So, but who knows? For example, the new Audi A4 with 4-cylinder inline.
They use like the VVTi system for as an EGR, no?
Exactly. Yeah. So, on some car, on modern car, to make everything simpler, they just use the VVT for the same thing. So then you have, after working cycle, then you blow out the exhaust gases. They just close the exhaust valves earlier to left some exhaust gases inside the chamber. So you reduce the volume of the chamber and get less mixture. So probably on the modern cars, we will see the EGR less as the system outside of the engine. Okay, so next the VVTi, how it's working. What do we have? Let's take the Mercedes engine, for example, like 276. So first of all, we have the magnet, this needle here. What goes next?
The valve, the solenoid, whatever you want to call it. Plunger.
Like center bolt of the camshaft adjuster here. And the last part?
The phaser.
Yes, that's correct. How this system works.
Is it?
I know it's oil pressure
Hydraulic.
control. It's like hydraulic control. When you add it, it makes the camshaft rotate so that it can, or when it takes away oil pressure through the magnet, it rotates the opposite way so it can control like to advance or retard. You can.
Okay. Yes. Let's start from the beginning, from the adjuster. How it's designed on the most cars. You have the chamber. Looks like that inside.
Are those veins? Veins?
Yes. So when you get oil, this is the normal condition. So that. Outside, you usually have the big lock spring that hold the adjuster on the basic place.
Retarded.
So then you have no pressure, it's on the same position every time because of this spring. Then you start the engine, initially it stays in the same position. Then the ECU wants to move the camshaft, so it sends a signal to some electrical magnet. It's press the needle to the center of this valve, move the piston inside, and here you have your camshaft. On most cars, the camshaft have the oil channel here. The adjuster is connected, so it sends the oil pressure through this valve inside the adjuster and put this the oil pressure through these veins. So the pressure press to these things and move them. The ECU use the oil pressure for calculation to how long he need, how, it's not how long, it's the PDM signal here. So what the frequency need to move the camshaft and control it by the camshaft position sensor to check how much degrees we already have. Then we reach position, it's slowly stop putting the more oil inside, and then you need to get back, it's just remove the needle, it comes back, open the channel to drain the oil from the system, so the clock spring just push oil out and put the internal part back to position. So what can broke on this system? Yeah. So the magnet. If we have the broken magnet, it can cause the codes for like, but no movement at all, for example, or it can open for some cars like Jaguar, Fords with Ingenium engines. They have problem that this needle stop. Sometimes it go out and stop. In this case, you have the opposite report that the timing over advanced. Yeah.
Camshaft position sensor.
It usually gives the
And most of the time it's just oil related. People don't change their oil, so it
Yes.
starts building up sludge and
a lot of time you have the tiny mesh on these channels, it's clogged and it not let the oil pressure go through, so you have same timing codes. And of course the adjuster itself, so due to the wear on these cameras, there's no seals, nothing, so you just have wear between the body and these flaps, and oil start leaking around them, lose the pressure, so we cannot hold the actual angle. So that all three of them can fail, or your problem cannot be related to any of them, you just have no oil pressure, for example, like
a BMW I'm working on right now, the oil filter cap is missing the cage. So the oil drains overnight. Every morning they start up the vehicle. They get a rough idle for a few seconds until the oil pressure goes up. And I get a PO12 and PO15. It's just because the freaking cage is not the oil pressure.
yeah.
I mean the oil filter.
Then the question for here would be like, how do you know how to test for each individual things? Like, depending on the code that you get, or
Depends of how hard to test, how hard to replace that. So change the magnet, it's pretty easy.
right?
So you can just swap them first. If it's not helps, the problem somewhere inside. To take out this part or this part, it's same amount of work. Anyways, you need to disassemble the timing. So just replace these two. So
If that is, let's say I'm looking at a car that has a system and I'm doing a timing job on it, would it be good practice to just swap it out while I'm doing the timing? Or just leave it there?
depends of mileage, of the price of the customer. It's more question for the advisors. How can they sell additional parts for it?
Yeah, if you're doing a timing chain, you sell the facers as well.
Yeah.
Sell the whole thing. They're gonna wear it too.
On the some cars, for example, the Porsche Cayman, they have this system, they separate this system. So they have magnets they have this valve here, but they also have another solenoids on the back of the engine. So this solenoid on the Porsche engine work only as a drain, but creating the pressure is another solenoid on the back. It's pretty weird system. I don't know why they did that, but maybe it's just because of construction of opposite engine or something. So the easiest way you get the codes, first of all, just check the actual data from the scanner. So what exactly you have. Especially on the V6 engine, it's easier. Or many cars have the target angle and actual angle. So if you see, for example, that you press the flip the throttle, the angle moves. So the black line is your target angle that the ECU wants to see. In real life, usually if you look, the actual angle have a little delay and must look like that. This is the good working system. If you not reach the angle
The apex.
here, so probably there's something with your any of them. If you have delay, for example, on a many system, on many cars, I saw that it goes up.
What is it that you're reading right there? Oil pressure or?
No, it's actual
Oh, it's right there.
timing. Yeah, camshaft position. On some cars, if you have problem with mesh here, it can create pressure but drops it really slow like that. Instead, rapid change. If you can compare left and right side of the engine, it gives you more information because sometimes the difference is not so noticeable. So
Until you see the other.
just if you can compare. But if you have no movement at all, or for example, as the Audi Q7 you did once with the 3 supercharged engine, the target graph looks like that, but you have graph like that. So your timing is never came to the target position. So it can moves but cannot came back. What this doesn't mean.
Those scan page?
No. Usually that means that your timing is off. So your gear rotated on a camshaft or jumped.
was never in position.
So yeah. So the ECU still can control, still can move, but the damage already received. It's already turned. So even then the spring came back, it stays like on 3-5 degrees because it's already jumped on the tooth. So it physically cannot came back.
So just to be clear, you're saying it's off by a tooth?
Well, the time is off.
But yeah, that's what I mean.
Yeah, tooth
For some
and chain
reason,
can be elevated.
it's a
Or like-
chain, broken guide, or
Okay.
something else. So it just physically moves the camshaft.
Okay.
The PCV, the last one. How works it? Sorry. So PCV, how it works. So we have PCV valve that we love to replace.
Actually, pretty good at drawing, dude.
Yeah.
Yeah, your cams are out of this world.
The camera, I was like on point. I couldn't come up with that on my own.
So how it's connected to something, why it's on the engine, what it's doing.
It's relieving the positive pressure that is created in the body of the engine, crankcase.
Okay, so where it's connected?
On the top of the block.
Yes. But usually you have like,
The hose going into the intake.
Yes.
To the intake, yeah.
yeah. So let's see that, for example, the air filter here.
Oh, custom.
Yeah.
Street racer.
Intake manifold. Star Wars.
The AT-AT.
So, okay, so why we have connect the PCB to two bases?
So we don't release the pressure to the atmosphere.
So, when the engine is working, where we get the, why we get the positive pressure inside? Yeah, so the pistons, it's not completely sealed, so they leak the pressure every time inside the crankcase. So the PCB, we have usually the membrane here, the spring that opens and closes channel. So let's talk about the turbocharged cars. So usually in intake manifold you have the most powerful vacuum. So the best way to get vacuum is take it from your intake manifold. But on a turbocharged engine, when you accelerate, you get pressure here. So you cannot take the vacuum from here anymore. So you have one-way valve here that blocking the pressure go into the PCB. So in this case, you have like additional way. It's from the intake. You have some vacuum after your air filter. It's less than intake manifold, but it's still working for the time when you're accelerating. It's enough to keep some vacuum inside the engine. So why we not just open the crankcase outside and put filter? What it changed?
Because you don't want to contaminate the atmosphere.
Yeah, first of all, it's the emissions. Because it's like a burnt fuel or exhaust gases, so everything what we need to
Burning.
go through the catalytic converters. What else?
Or is oil, like if you have too much vapor, you make it nice.
Yeah. Yes, for that you have the lever.
Yeah, I mean like you want to have a closed system, like no leaks.
Yeah.
So you have no vacuum leaks.
Yes, it's also not get the air from the outside, unmetered air. And the last one is help your seals. So if you look on the any shaft, you have the seal and it usually have a lip on it, like that. So the vacuum just suck this lip in to make it have better contact with the surface. That helps your seals working better. But you need to have specific vacuum. On most cars, on the European cars, it's millibars usually. So you usually have from 20 to 100 millibars of vacuum. If you have too much vacuum, what it can do?
seals are gonna leak.
Hmm?
Your seals are gonna leak.
Yeah, it can kill your seals. It even can
Just suck them
just
in.
rotate it in another side. So, for example, and also your one-way valve can be bad. I have one Volvo, so if you're doing the PCV on Volvo, always put the OEM one.
Yeah.
Because advisor sold some aftermarket one on XC90, and in 2 weeks this small valve, it's inside the PCV. It's just same membrane but tiny, like
Right.
half inch. It just pops out, and all boost pressure go inside the crankcase. So every time that the customer press the throttle, you probably know that the Volvo have this cold oil cap. So I have it like a garden sprinkler that
Oh, yeah, sure.
the oil goes everywhere. So this part can fail. Also inside the PCV, or it can be an additional part like on Audis, for example, 2-liter TSI, they have the oil separator. So some cars have the oil separator inside. How it works, who knows? Why it looks like labyrinth,
Why it looks like what?
like maze.
Oh, it's to trap it from.
Yeah, so it's usually the channel like that. So your air go in, it have pretty big speed because it's very thin channels. So every time then the air change the direction,
Slow down.
the oil drops, they still have inertia. So they hit the walls and stuck on them. So by the end of this maze, almost all oil stick to the walls of this. That's also some have the cyclone type oil separator, but same principle. You just
Yeah.
rotate the air and the
It's like a
force just
centrifuge.
press the oil to the walls. So you separated your oil. It usually have some channel to drain the oil back to your oil pan, but this membrane that you have in the spring, how it works? Why we have this membrane?
So
Augment.
at idle, you have a closed system, pretty much, right? And when you start hitting the gas, the membrane's gonna move and allow the air to the pressure to move.
Not exactly. So it's not you need to have exact vacuum inside the system. So your vacuum inside the engine change every time because it's getting bigger or smaller inside the intake manifold. You have more crankcase gases. So everything changed. But you need every time have, let's say, 20 millibars. So this regulated by this spring. So if the spring goes bad, it will still work, but it can change. It can goes bigger usually. So then the spring goes compressed more. You have instead 20, you have, for example, 57. So the normal way to test the PCVs on the, for example, on the Audi, Volkswagen cars, usually, I don't know about you, we usually replace the PCV if the car have oil consumption. It's the first thing that we replace the PCV. The membrane is good. They have the problem with the springs because they have two options, 20 and 100 millibars. The 20 they usually use on transverse engines, and 100 they use on non-mutual. So then the spring goes bad, you significantly increase the vacuum. And that means that the speed of the air increase that go through the oil separator, and in many cases it goes so high that the oil parts still have time to go through.
Is
So
that a
you
prob-
suck the oil from your oil pan and burn it.
Is that a problem on the 2.0 Ts?
Yes.
That's it. That's the problem.
So
I'm consuming so much oil. Like,
So it's the first thing that we replace, because in many cases it helps. Of course, it can be the oil rings on your pistons,
Yeah,
for
yeah.
example, but on many cars replacing the PCV helps
Yeah,
to
okay.
reduce the oil consumption because of that. But the proper way to diagnose, you can buy the kit of the oil filler caps with a vacuum port, so you can connect the vacuum gauge and check the real vacuum inside your engine.
So what is the vacuum supposed to do?
It depends of the car, but for the Audi cars, for example, the 4 cylinders on the transverse, it's usually like 20-25 millibars. On a longitudinal, it's 100 millibars. So when you're replacing the PCB, just look exact on the part number, because physically the PCBs are the same, but it will not work if you replace them, because the ECU also measure this air flow through. So if you have more vacuum, you have bigger flow through your PCB, and its effect to your mixture. So how to control this exact? So the spring control the vacuum. So it's the membrane that closes the channel here and a spring. So if you have too much vacuum, the spring compressed and close the valve. In like thousands of the seconds, the pressure inside crankcase starts growing up. It's growing more to let the spring comes up and open the channel. So it's like instant movement of this membrane. So your vacuum would be not like consistent. It's just looks like that. So because this valve every time opens and closes many times to control this vacuum. So if you have the crack somewhere on membrane, it still can close it, but it's affect to everything, and usually instead 20 millibars, you can get more or less, depends on design of the PCB. Any questions?
probably.
So that's all for today.